Hello everyone. Today I am going to explain the convolution, how the convolution can be done in MATLAB, the detailed procedure of MATLAB code for the convolution. So we'll take the help of, we'll follow this document, discrete convolution. Hope you all know already the detail about the convolution, how mathematically or numerically we do the discrete time convolution. So basically in this lecture or in this video lecture, our primary objective is to find out to figure out the efficiency of the CO and V functions. That is, as you know, there is a built-in function in MATLAB for doing the convolution, which is CO and V. But there is some deficiency. We'll try to figure it out, what is the deficiency, and we'll try to make our own program and function, MATLAB user-defined function, to perform the proper convolution sum along with the index calculation. Index means time index. Now, convolution, as you know, briefly I'll tell you about the convolution, which is the mathematical operation of two functions or two discrete time signals to generate a third one. In the signal domain, in the time domain, convolution is the operation on two signals to generate a new signals. That is basically to get the response of an LTI system. This is suppose an LTI system with the known impulse response here, h of n. Now once the h of n, that is the impulse response of an on LTI system, is known, then for any arbitrary input x of n, you can calculate the response, that is the output y of n, as the convolution of x of n and h of n. The output yn will be the convolution of the input and the impulse response of the system. Basically, convolution two types. For continuous time LTI system, the convolution is convolution integral, that is denoted or represented by this y of t, x of t convolution h of t, integration minus infinity to infinity x of tau h of t minus tau d tau. And since convolution is commutative, so you can have h of tau in x of t minus tau d tau as well. This is not our concern here because we are going to deal with the discrete time convolution only. So in discrete time, the similar formulation, which is y of n is equal to x of n convolution h of n, and is summation over sum k minus infinity to infinity x of k into h of n minus k. And since convolution is commutative, so h of k into x of n minus k is also same. And here one thing to be noted down is the range of values of k, discrete k, should be same as that of n. Now from this formula you can find out mathematically or computationally the steps involved to find out the convolutions. Different steps involved. First of all, suppose x of n and h of n are given, where x of n is the input, h of n is the impulse response. Then you need to change the variable from n to k for both the signals h and x. That is h of n to h of k and x of n to x of k. Then, as you can see here, the first step is flipping or the folding. So flip or fold h of k to make h of minus k. Since convolution is commutative, we can make this to x also. Then the folded h of k should be shifted left and right, that to get the h of n minus k index by index. And after shifting each and every shifting, you need to multiply it with the corresponding values of x of n or x of k. So carry out this process, and after each multiplication you should calculate the total sum. Then carry on this process till h of n minus k slides past all the x of n. So the values of the sum will be the convolution sum x of n and h of n. Okay, so here I am showing one example. Let us take one example for the convolution. Say x of n is u of n minus u of n minus 3. So what is un? Un is 0, 0 through infinity, 1, 1, 1, 1. So the values of un is 1 from 0 to infinity. And what is u of n minus 3? U of n minus 3 is 3 units shifted towards the right. So therefore, un minus 3, you will get value at 0, 1, value at 1, 1, value at 2, 1, and value at 3, 1. Similarly, suppose h of n is un minus 2. So it is 0, at 0 it is 1, at 1 it is 1, at 2 it is 1. And once you do the convolution of these two, you will get these results. So it has the 3 samples, it has the 4 samples, so there will be 6 samples in the convolve signal. 1, 2, 3, 4, 5, 6. Okay. Now thing is that there are few things to be considered while doing this process. First of all, as already I mentioned, in any discrete time signal, the starting index of x or starting index of h is the important one. Now the starting index of y, that is y is the convolution of x and h. So the starting index of the y will be equal to the starting index of x plus starting index of h. And the total number of samples in y, that is the convolve signal, is equal to the number of samples in x plus number of samples in h minus 1. So these two things, the primary prerequisite calculations before doing the convolution. Okay, so this is briefly about the convolution. So now coming to the lab task. So what we do in the MATLAB. So here I am writing that by reading out the pre-lab documents, this briefly, most of us would have the idea about the convolution already in theoretically we discussed, but that was how we perform the convolution mathematically. So in this lab we will explain how convolution is done in MATLAB by explain step by step procedure. First of all, we'll make use of the function, that convolution function, conv function, available in the MATLAB. Okay, so MATLAB provides a built-in function which is conv x comma h, conv x comma h, that computes the convolution of two discrete time signals. Suppose let us take these examples. Again, MATLAB. This is your command window. I am opening up the command window. Directly this I will do it in command window. Suppose this is one x, and suppose this is your h. Here there is nothing mentioned about the time index of both x and h, because I'll tell you in this function conv, it does not take into account of the time information or time index. So these are the values of y. These are the values of y. Now thing is that if you look at this help conv, it does not take into consideration of the time index of both x and y. That is the deficiency of the using of this function conv. As you can see, this conv a comma b convolves the vector a and b. The resulting vector is the length maximum of length of a plus length of b minus 1. That is true. If a and b are vectors of polynomial coefficient, convolving them is equivalent to the multiplying the two. So there is nothing about the time information while using this conv function. That is the deficiency of the built-in function conv. So this convolution function proves to be very useful, but it misses one of the most important things of the convolution, which is discussed below. The conv function assumes that two signals begins at 0. since it does not consider the time, so that means default is it takes it as 0. Moreover, this function neither provides nor accept. It does not provide also nor accept any timing information. If the sequence have arbitrary starting point, it may have the signals in the practically signals may have starting at some negative index, some positive index, or maybe 0. But this function does not provide or nor accept any timing informations if the sequence have arbitrary starting points. What is required is to beginning and end point of y1. So as I mentioned, the beginning of the yn is the starting point of x of n plus starting point of yn. So that will not be provided by this CNV function. So for a given finite duration x of n and h of n, it is easy to determine the points. For example, x of n is your signal, which is starting point is suppose nxb and ending point is suppose nxc, and your h of n is suppose nhb and nhe. So b to the finite duration sequence, then starting and ending point of yn can be, starting point of y will be nxb plus nh and hb and xb plus nhb, and starting point ending point of ny, that is nye, is nxe, that is the ending point of xn and ending point of hn. But this sort of information is not provided along with this CONV, this built-in CONV functions. That is the deficiency of CONV. So that is why we don't suggest to use this CONV directly while doing particularly explicitly the convolution. But in some situation where we don't require precisely, don't require the timing information, but only the convolve sum is required, then of course you can use this. But where precisely the convolve signal should associated with the time information, then we should not use this CONV functions. So therefore we should develop our own program. So separately, in a different way, I'll explain how we can develop our own program, a MATLAB code for the convolution. So therefore I mention it as a task 2, the making our own MATLAB program for convolution. So with an example I'll explain. Okay, suppose this is my x of n. This is my x of n. In this x of n, how many samples are there? Total 9 samples. So what is the starting value? This is suppose at 0, so it is -1, -2, -3. So my nx1, which is the starting time index of x of n, which is your starting time index of x of n, and this is the number of samples in x of n, and so how we calculate this? The ending time index of x of n, already in many of examples we did it, and x1 plus lx minus 1 is equal to 5 here. So because nx is -3 plus 9, so it is 6 minus 1, 5. So it is the ending time index of x of n. Okay, so therefore the total time nx, which is nx1 to nx2, which is equal to this time scale for, which is the time scale x of n. Similarly, this is suppose my h of n. So this is start at -2. This is start at -2. So this is starting time index of h of n. Then LH is suppose my number of samples. So here 1, 2, 3, 4, 5, 6, 7, 8 number of samples in h of n. Okay, and similarly here nh1 plus nh2 nh2 nh1 plus LH length minus 1 is equal to say 5. Here also -2 plus 8, so it is 6 minus 1 5 number of samples in your h of n. So therefore your nh, the time scale for h of n is nh1 to nh2. So this is the time scale for your x of n, h of n. Now as we know that a convolved signal will have the number of samples which is equal to the number of samples in x plus number of samples in y minus 1. So which is the number of samples, which is the number of samples in y of n. So what is y of n? Y of n is your convolved signal. So then the starting time index of the y of n, will be your starting time of n x of n plus starting time of h of n. So here my starting time of x of n is -3 and starting time of h of n is -2. So therefore starting time of y of n will be -5. So this is my starting time of y of n. Okay, and the ending time is number of samples, this is n, plus starting time -1, or also we can calculate it as the ending time of x and x2 plus and h2. That also be the correct. So nh2 is 5 and x2 is 5 and h2 is also 5, so it is also 10. Okay, so ny is your ny1 and ny2. Okay, so these are the prerequisite calculations before doing the convolution. Okay, before doing the convolutions. Now let's see how we can do at least up till this in MATLAB. So here in this code, this is, now remember one thing here in this code, particularly this for convolution.m, in this code what I did is I willingly make a bigger code to explain each and every minor detail of the convolution, but in practice you can make short this code. I'll tell you how to make it short later on. Let me first explain the detail code. That is why I have write one comment line here that this is a generalized program for the discrete time convolution. It covers all the steps of the convolutions. And also I mentioned here, you see this code is just for explain the student each and every steps of the convolution. Later on I'll make it short. Okay, so CLC clear all closure. So next one, for getting the starting time index, x is to get the signal values of the x of n. Now here I have incorporated one more thing. Suppose the signal that you have entered means nx1 that you have entered a positive integer instead of negative or 0. If you have entered positive, say for example nx2 you have entered 2, positive 2. So that therefore at 0 it is 0, at 1 it is 1, at 1 it is 0, then from 2 actual signal will start. So to make at least a reference point 0, at least, even though it is not negative, at least at 0. So I'll make if nxn is greater than 0, then I'll make that many zeros at the beginning. That means actually my signal will start from 0, but the values will be, suppose you have entered nx1 as equal to 2, so then at 0 it will be 0, at 1 it will be 0, and from 2 onwards the signal will be. Okay, so here is the to calculate the length of the x, then nx2 already we discussed, nx is this, then similarly nh1, h, again the same concept. If nh1 is greater than 0, then that many zeros will be incorporated to make the signal started at 0 with the value 0. The length of this length of 0, length of h, then ending time index, then the time scale, then total number of samples in y, starting time of the y, ending time of the y, and time scale of the y. Okay, now as a first step of the convolution, that is the folding, so you have to make fold the signal. So if you can fold x or h because convolution is commutative. So let us fold h. So what is my h? H is this. The values of h are 1, minus 1, 2, 5, minus 3, 6, 8, 4. Now once you fold it, it will be 4, 8, 6, minus 3, 5, 2, 1, minus 1, 1. So 4, 8, 6, minus 3, 5, 2, minus 1, 1. And what will be the time scale? It was started at minus 2 and ended at 1, 2, 3, 4, 5. So the folded time sequence will have the time scale from minus 5 to plus 2. So you see, minus 5 to plus 2. So this is the folding. Now this folding part already we did it in separately in MATLAB program, how to do the folding. So exactly the same. Here I am creating one blank matrix, providing zeros. 1 is the number of rows, each length of each, that many zeros. So h of f becomes a 0 matrix. Then for I is equal to 1, throw that length, and it is last value the first value, second last second value, third last third value, likewise it is doing, and the folded time scale. Okay, so now all these three signals are plotted here. The first signal x of n, then h of n, then folded h of n. So if you plot it with that example, it will be like this. This is your x of n, this is your h of n, and this is your folded h of n, h of minus n. Okay, so now as you can see here, the convolution results from minus 5 to, because the starting value of the convolution signal will be minus 5 and ending is 10. So your convolution sum, if you will look at the formula, in this convolution formula, in this convolution formula for that particular example, this will be from -5 to +10. So -5 to +10. So therefore, since it is from -5 to +10, how many left shift? How many left shift will be there? How many left shift? So 5 left shift will be there. And how many right shift? 10 right shift will be there. So how will you calculate that how many left shift? So it is starting point of h and starting point of x negative. So minus of minus nh1 minus nx1. So it is 5. So total there will be 5 number of left shift. Okay, as you see, this is a left shift means h of n plus k. So it is h of n plus 1, h of n plus 2, h of n plus 3, h of n plus 4, h of n plus 5. Now if you further shift it, then what you will see, as I mentioned in the steps of the convolution, carry out this process shifting, multiplication and summation unless h of minus k slides past all the x of n. Now if you see here, if I shift one more, this is up till -2. Again if I shift one more, then it will go to the -3, right? So -3 will also be 0, right? But if you look at the x is having the value up till -3. So if I shift it one more, left shift, then it will not overlap with any one of the samples with x of n. That means all will be 0. So therefore up till 5th shift only left shift. Get it? So how do we have calculate automatically? Minus h nh1 minus nx1. So this is how, see, shifting h of minus n, then multiplication, then summation. So left shift. So here I am using the variable l underscore l, left shift, which is minus n of nh1, that is the starting point of h, and minus nx1, that is the starting point of x. So again I am creating a 0 matrix with that length. How many? 5. LL will be 5. Okay, 1 comma 5, that is 5 zeros will 0 matrix will be created. Then I have initialized with a variable k with that value. Suppose this becomes 5 for this particular example, so k becomes 5 now here. Okay, now for I is equal to 1 through 5. So in every shift, okay, so for h of s1, hf, the values, whatever be the value of folded signal, h of f, h underscore f is your folded signal. So that values hf and that many zeros, 1 comma I. How many shift? I is equal to 1, so I is 1 zeros. As you can see here, this is the first shift, and when it is first shift, 1 0 is placed that at the original position, because originally this is say 2 1 0 -1 -2 -3 -4 -5. So this was your h of minus n. Now once it is shift, 1 unit shift, so that shifted unit is being replaced by a 0 here. So this 0. So how do I plot it? And the time scale, you see time scale is also changing. Here as you see, it was originally from -5 to 2, now it is -6 to 2. Okay, the shifting program already we did it, that the same concept is being applied here. So the new time shift for the first shift is minus nh2 minus I to minus nh1. So I is 1, so nh2 was here -5, now it is minus, so -6, and it is your 2 minus nh1, that is minus plus 2. Okay, then multiplication. So for multiplication, as you know, we have multiplication or addition, whatever we did already in another previous program. For now, what to do? This signal 1 unit shifted has to be multiplied with this. So while doing multiplication, it is always sample by sample multiplication. So for doing so, what we need to do is I have to make equalize the number of samples, and also the corresponding indexed samples will be multiplied. Okay, so that means the sample at 5 will be multiplied with the sample at 5 here, but here though there is no sample at 5, so we have to make it equalize with putting zeros, that as already we did in signal arithmetic in previous program. So that part is done here exactly as we did in the previous program. So zeros 1 comma minus nx1 minus nh2 plus I, and that the signal fs, the folded signal, that means this one. Okay, then also 0 in the rightmost. Okay, similarly you need to modify the x also. These two steps exactly we did in the previous program while we have done the signal arithmetics. Okay, so to make the number of sample equalize also in corresponding time indexed. So once this is done, the next step is to do the multiplication and followed by summation. Now here both the operation is done together. As you know, the normal matrix multiplication in MATLAB, if it is only star, then it is normal matrix multiplication. If we would like to do only multiplication, then it has to be dot star. So what we did in the previous mathematics signal arithmetic, we did separately the addition, separately the multiplication. Okay, so here what we did is, what we have done is here the matrix normal multiplication, because matrix normal multiplication is multiplication plus addition both. So but therefore one has to be in a column matrix. So therefore this is in a row already, this one after putting the zeros and all h, and x of L, which is after putting the zeros. So this is transposed, this prime here, this prime does the transposition, that means it becomes a column. So once it becomes a column, so it becomes normal matrix multiplication, and normal matrix multiplication means it is multiplication and addition. Okay, so that means this y underscore L now having the final result multiplication as well as summation for all the left shift within this loop. Okay, within this loop. And here, since I am using this is for the left shift, since I am using this is for the left shift, so first value will be the last value. So therefore I have initialized k with 5, L of L, which is 5 in the given example. So k is 5, so it becomes the first one will be the k5, y of 5, then will be k minus 1, so next will be y of 4, next will be y of 3, next will be y of 2, next will be y of 1, next will, like that it will go on. Okay, because it will be from left to right. Okay, and how we plot this, the shifting part. So it is a subplot to cell. This subplot, actually this first is the number of rows, second is the number of columns, but here it is a variable, so therefore since it is the L underscore L gives the number of shift, so it is 5, so 5 divided by 2.5, so it will be 3. So in this particular example it is 5, it may be different, so that is why I have make it like this, and I is the number of figure 1 2 3 4 5. So accordingly you see 2 rows but right now it is creating 3 columns. If it is other than LL is suppose 7, then it will create 4 columns like that, and stem. Okay. So in another figure, this figure is written to create another figure where I am showing the right shift. It is not necessary to make it separately, just to explain only I am making it separately. Okay, left shift, right shift. So as we did in the left shift, similarly this part exactly same, exactly the same we did in the left shift. Okay, exactly. So how many left shift? 10 left shift. So y l comma r will be your 10 in this given example. So therefore there will be 10. You see. So okay, finally your y of l left shifted values will be this 5 minus 1, 12, 13, 34, 13. Now total number of right shift will be 10. So these are the 10 right shift. After each shift, this is being multiplied with this and take the summation, then this will be multiplied with this, take the summation, and so on and so forth for all these 10 shift. Okay, so I hope you understand how it is 10. How it is 10, and h2 plus nx2, which is 10. As you can see here, if you shift further, there is no values of x that is overlapped. So because it goes up to 5, if I shift it 5 minus 3 to 5, okay, so if I make it 10 shift, there won't be 11 shift, there won't be any values of x which will be overlapping with this. So that means all the results will be 0. So therefore there can be only 10 shift, right, 10 shift. So here I did this part gives you that almost same like this, same logic. So this L underscore R will be your 10 for this given example. Again I am creating this same blank matrix with 0 matrix. So for 1 to 10, this again the same principle only, and this YR is all the values in the right shift. And see here, as like this k is equal to this, I have not done here because it is from left to right, but while it is calculating, it is right to left. So therefore I am making it ulta, I mean opposite. So k, suppose 5, then 4, then 3, then 2, then 1, because it goes towards the negative side. But here it goes towards the positive side. So from 1, 2, 3, 4 like that only. Okay, and finally the left shifted values, all the this YL and all the right shifted calculations Y of R appended together, concatenated together to form the complete result. So this is your complete result. Okay, so this is the program, the same program I have. Sorry, this is another program. I'll tell you. This program I have not. Okay, so let us run it. Somewhere. Okay, enter the starting time index for the input x of n. Say I'll use this same example. Okay, I'll use the same example. Say -3, then x of is this. This is your x of n, then your h of n. H of n is this with starting time index -2. So the starting time index is -2. Then values of the signals. Okay. Just running, so busy. So you see here, these are the results. This is your input h of n and impulse response as this, as I have already taken the same example, this example only. Then this is your all left shifted values as I have shown here. This 5 left shifted values. So these are all 5 left shifted values. Then this is your all right shifted as I have shown here. All this right shifted. So here is all this right shifted. Then as you see, the nx, this is the time scale for x, the values of x, and h, this is the time scale for h and y. So your -3, -2, so your ny should start from -5, and here it is 5, here it is 5, so it will go up to 10, and y. This is the resultant signal. So you can validate that result with using the CO and V, x, h. You see, you will get the same values. This is the built-in function, but it does not provide you the time information. But the values you can check. It is same. That means it is correct. Okay. And this is your final results plotted. Okay, this is your final results plotted as it is showing here. This one. Okay. Now hope this program got clear. This is the detail. Okay, but in this so long program you need not to write. You can make cut short this program. Okay, you can cut short this program. So here I am showing you a shortcut program for the same convolution. Okay, so in this program I have written, again this is a generalized program for the discrete time convolution. This is without using the CO and V functions. So this part again same up till this. It is same. Then up till this is same as the before. Now what I did is that I am making equal number of samples in both x and h by putting some zeros. Only the vectors I am making equal. So x, my original vector, then putting zeros. How many zeros? So n is the final number of samples in y, minus lx. Lx is the number of sample in x. So in this present example, if you see, my total number of samples in x is 9, and my total number of sample in y will be 16. So this is 16 minus 9. So therefore 7, there will be 7 zeros along with x. So to make it total 16. Similarly in h also. Then I utilizes the matrix method of convolution. Okay, as we did it in theoretical class, the matrix method. So this part is to creating the matrix. Okay, so the result of this, I'll tell you how it is creating. Okay, so first, as you see, this H, the blank matrix, for I is equal to 1 to n, for j is equal to 1 to n. Then this particular logic loop will create the matrix something like this. I'll just show you here how it is actually creating. So your H is, with the same example only I'll do it. So your H is this. H of n is this. Okay, H of n is this. Now if you look at this, so 1 to n is your 16, j is 1 to n is your 16, I is 1, j is 1 minus 1 0, plus 1, that is 1, greater than 0, yes, h is 1 comma 1, h I minus j plus 1, that is h of 1. Okay, else this. Now this is done, else will not execute. Getting? So next time I is already 1, j is 2, 2 minus 1, 2 minus 1. Okay, 2 minus 1 minus 1. Sorry, I is 1, 1 minus 2. So minus 1 plus 1 0. So it is not happening this. So else h of 1 comma 2 will be h of 16 plus 1 17 minus 1 minus 2 15 plus 1, that is 16. So how it is happening, you see here. So it is, I'm just showing you. So it will be 1, then 1, minus 1, sorry. Okay, this way will not work. I'll just show you. So first will be 1, minus 1, 2, 5, minus 3, 6, 8, 4. So once I put it like this means folding. Then 0, 0, how many zeros? Total 16. So how much it is? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that, 16 zeros. Then it will go like this way it will go on. It will be go like this way. Okay, so that means it will create the folding and shifting together. The matrix will together create a matrix which will be folding and shifting. Okay, in this case. After that, once this matrix is created, then the transpose of X matrix, capital X, which is already with the zeros, that is 16 samples. So transpose X prime is transpose, then normal matrix multiplication, which involves multiplication summation. It will become a column matrix, then finally again transpose. Okay, so this is using matrix method. The same thing you can do either this is or you can do it using this also. So this is the here the matrix is created separately, that HS matrix out of H of n, and then multiply and take the summation. This single star is multiplication and summation. Folding and shifting is done here, and then multiplication summation is here. But here, furthermore compact of this, here actually matrix is not separately you will get, but within the process it multiplies and take the summation as well in this loop. Okay, so finally y will be your result, final result. And here also again I am calculating this using built-in functions. So let us run it. So I'll use the same example again, minus 3. Then minus 2. Okay, so this is the final outcome, your x of n, h of n, your y of n. So let us see in this command window. So your nx is this, x is this, and h is this, then ny, then y. Sorry, so here it is capital Y, yes, capital YY. The first one is capital Y. First one is capital YY using that matrix method. So it is capital YY, capital YY, then capital Y, same results, capital YYY using C and B, same results. Now look at this H. This is your H. Sorry, HH. This is the HH. You see how this following. This shifting 1 unit shift, shifting 16 times total, right and left. Like this is shifting. Okay, So one this, then 1 unit shift that goes down, 2 unit shift it goes down, 3 unit shift it goes down, 4 unit shift, 5 unit shift, 6 unit, like that. And the matrix method. So in a shortcut, this program, it explains the detailed steps. In this second program, the same concept only, you can follow either this method or this. This is further little shorter than this part. This part is shorter than this part. Okay, this is just to validate. Okay, so this is actually the program. That is why this program I have given here. This is your or you can follow either this part or this part. Okay, hope it is clear. Next, as I have mentioned in this document, task 3, making our own convolution function using conv function. Now, this is we develop our own code, this or this, but still I can use the conv function also. Okay, thing is then, as it is mentioned already, that in the conv function, if I use the built-in conv command, where it will give you the convolution sum but does not provide any time-related information. But if we can manage the time-related information ourselves, then we can use the conv function along with it. So let's see this example. So the same code again, up till this is same, up till this is same, as already explained in both the programs, previous these two programs. Only thing is, this process of convolution is being replaced by simply conv. Okay, using conv. Because if I do the conv with this, with the built-in command conv, if I do the convolution using built-in command conv, and before that if I have already my time calculations, then along with this y I can get ny also. That's all. Okay, so that is how we can make use of conv as well, if we have prior calculations of my time index. Okay, so better to use it as a functions. Like these built-in functions, we can make our own functions. It's very easy in MATLAB. Let me explain how we can create our own function. So for this purpose, I'll make one functions. Okay, so this one, in this you see, so while creating, this is not M code, this is M functions. The extension here is, so here I'll explain how to create our own user-defined functions. Okay, the extension here is also .m, but this is function, not like this M code. Okay, this is script and this is function. So to start with the function, I means to design a function built-in or user-defined function, the first thing you have to write function. This is the keyword function, or you can say command function. Then within square bracket, if it is more than one, if it is single, then you need not to provide the square bracket, is the output argument. How many output arguments you need to get. Okay, so here I am giving 2 y for my signal output y, convolve signal y, and ny is the time scale for my signal, convolve signal, time index for time scale for the convolve signal. So I need to have 2 output variable. It may be a single element value or a vector, but it has, if it is more than one output argument, then it has to be within square bracket, and is equal to the name of the function. It is just a name. any name you can put. I am just giving my conv. Then within first bracket you need to provide the input arguments. What are the input arguments? Now to do the convolution with proper timing, what are the input arguments need to be there? The input sequence along with the time, then the impulse response along with the time. So there are 4 input arguments at least minimum needed. So x, that input signal x along with its time scale nx, the impulse response h along with its and h. So here I have written the command line. Y and y is the convolution result, x and x is the first signal, h and s is the second order impulse response. Okay, now here I am using one ny1. The logic is this much only, very small. ny1, that is the starting time of the y, convolve signal y. This is nothing but the starting time, because here I don't know, this program does not know what is nx1 and what is nh1. Okay, so therefore I have written nx within bracket 1. It means it will take the first value of nx. Here you will provide the nx, no? So suppose it is -3 to +5. So -3, -2, -1, 0, 1, 2, 3, 4, 5. So nx within bracket 1 means -3. So it is -3. Similarly, nh1. Okay, nx1 plus nh1 is the starting value of the y. Now this is starting, okay, but ending you don't know, because in generalized program you may have any length signal, any length time indexed. So therefore, as you know, the ending time is the ending time of x plus ending time of h. But I don't know, in this program it is generalized, so it does not have the prior knowledge about what is the ending time index. So therefore nx within bracket length of x. Okay, length of x. So length of x, suppose there are 7. Okay, so nx7 will be the getting the point. I'll explain with this example. I'll explain with this. Suppose this is your signal 5, 4. This is the value. So starting time index is -3. Your nx is -3 to +5. Okay, so therefore if you look at it, nx1, so what is nx1? nx1 is -3. Okay, now ending one, this 5 here you know, but in that function it is not known. So how many samples here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So as you see, nx, length of x will be 9. So nx9. What is nx9? nx9 is 5. Got it? So it is 5, like that. So therefore ny is ny colon ny2, and simply y is conv x comma s. That's all. Okay, so this is the function, and in this function get ended here. So you just save this, but remember, while saving the function, the file name should also be, you see here, the file name should also be exactly same, case sensitive, as that of the function name, and it should be within the same folder where you are going to write the program to whom, within whom you are going to call this. So I am writing one program here. Okay, main program, convolution using my convolve. So again, up till this is my same as the previous one. Okay, now I am this part is now not required. This part is, see, as here this part, this n is also not required. So this part was required while using conv, but here, since that ny part get calculated within here, within this function, and I am calling this function here in this program, so this part is not required. So I can make it delete here. Okay. So this y and y, you can use the same variable, you can use the different variable here. Instead of y, you can say pq, no problem. It does not make necessary that the same variable you have used here have to be used here, no. Okay, so y and y, my convex, this should be now same as this, and this program and this program must be within the same folder. So x and x, h and h, all the arguments that you have allowed should be passed here. Okay. So you'll get that same results. Now let us see. So I'm using the same example again. The plotting part I have not done here. You can make this use of the plot here, plotting part. So let us see here. So y, so this is your y, and y, this is your n, that's all. See how good it is. In one line I did it with this small functions defined. Okay, so now coming to this, so making our own CONV functions. So that part here, let me do one thing. This is the function. Okay, this is our own defined function named myconvo. Now we can use this function. Okay, next task for use of this in a shortcut. Outputs. Right. Okay, start till this is done. Then task 5, what you need to, this is for you, these two signals you need to consider. Same signal, you need to do the convolution. You are required to write a MATLAB code to find yn, plot x, h, y, level it, apply the grid. Okay, then task 6, this is x of n you need to consider, this is h of it you need to consider, and do the same thing. Okay, then task 7, probably this is assignment 3. When the convolution of a signal is performed with itself, it is called correlation. Okay, correlation actually I have not explained in theoretically. I'll explain it. So which is a very important concept of communication. This task is related to this concept, so you need to do the correlation. But okay, you just consider of this assignment, but before that I'll provide you detail about the correlation. But along with, you need to do one thing. you have to answer these questions. Okay. What is convolution? Explain the type of convolution. What are the different steps to carry out the convolution? How will you find convolution in MATLAB? What are the difference between the plot and stem? How will you apply grid on graphs? How will you write action in MATLAB? With this action, you need not to submit it to me, but you need to answer yourself this time. Okay, thank you. For any further query, please contact me.